This is Dylan Sieverts going over wind tunnel measurements and calculations steps 2 through 4. So as you can see here, I have a box fan. I originally built a circular wind tunnel at work. However, I got locked out of my work after a certain time. So I was unable to use that and I had to switch to a box fan. So I basically have a box fan that's 19 inches by 19 inches exactly. I took 7 different measurements at the entrance, discluding the center measurement because of the center of the fan blade with no air velocity. At that point, I got an average of 2.7 meters per second squared. I took the exit velocities at the same places, but was able to include the center air velocity and obviously divided that by 9 components instead of 8 and got a slightly smaller number. It was really close. And for the entrance area, and I spelled that wrong. Basically, just length times width. That was in inches, so I had to convert it to meters. And then the volumetric airflow. I went through chapter 14 with my group, but none of these equations were really in chapter 14 PowerPoint and lectures that I could see. I was unable to find the chapter 14 video example since that was mentioned. But anyways, basically Q of T stands for volumetric airflow. You're taking the derivative of that with respect to time, and then your area times velocity is always just going to be some number or constant. So therefore, once you integrate, not differentiate, integrate, you get your time. And from the other groups that we talked to and my own group members, we found that you wanted us to take it at 1 second. And so that's what I did. And same thing down here, which I didn't put in because it's 1. And I got the entrance volumetric airflow from these calculations here and the exit. And this is for part B. This was a harder thing to find. I couldn't necessarily find the density of the air in Salt Lake City, Utah. So I took that value from a graph that I found online. And I'm not sure if that's accurate or not, but I can always go back and change it. And same thing as above, my area times velocity gives me my volumetric airflow. And so I was able to plug that in and multiply it by density and the 1 second time frame and got those values. And lastly, this was just the volumetric airflow and mass of air that was lost. So that was basically just the change over 1 second, which I calculated above from the entrance to the exit. And that was the difference. And that is all. Yeah.